Hey everybody, we're going to go through the last two slides now. We're going to find some compositions. So composition, just a reminder, is when you have a function inside another function. So we're going to find the exact value of sine inverse of sine of negative pi over 8. So let's just think about what this is really saying, okay? First of all, pi over 8, negative pi over 8, is an angle. And if I plug that into sine, this is going to output some y coordinate on the unit circle. Now, it's not one of the values that I know because it's not part of our memorized unit circle, but it is a value. It is a y value on the unit circle. It would probably be negative because it's in the fourth quadrant. And then inverse sine would take that y coordinate and spit back out the angle that created it. Since we were given the angle to begin with, we end up with negative pi over 8. Now, because negative pi over 8 is in between negative pi over 2 and pi over 2, it falls within the range of my inverse sine function, and so it is an acceptable value. All right. Looking at the next example, though, inverse cosine, if you think about the first one, these kind of canceled each other out, and we were left with negative pi over 8. Now, in the second one, the inverse cosine should cancel out the cosine, and we should be left with 5 pi over 4. But the problem is 5 pi over 4 isn't some angle that I can get out of inverse cosine. Remember, inverse cosine only goes from 0 to pi, and since 5 pi over 4 is pi over 4 past pi, this is not an angle I can get out of this function. And so what we have to think about here is what's the equivalent angle to this that would produce the same thing. Okay, so if I think about my coordinate plane and my unit circle, right, 5 pi over 4 is this angle here. And so that's going to give me negative root 2 over 2. Okay, so this gives me, this value here is negative root 2 over 2. Now, what's another angle that produces a value of negative root 2 over 2, but is in between 0 and pi? Well, that's going to be this second quadrant angle, which is 3 pi over 4. So 5 pi over 4 seems like the obvious answer, but it's not something that this function would produce. Instead, what it produces is the equivalent angle that's between 0 and pi. And so we have to find that equivalent angle. I hope that made sense. Okay, let's do some other examples. Okay, so we're going to find the exact value of tan inverse, or cosine of tan inverse of 2 over 3. So if we think about what's happening here, tan inverse, this is going to give me an angle, and then cosine of that angle should give me a value. If I use the definition of what tangent is the ratio of sine over cosine. Okay, so tangent of some angle is equal to y over x. And so in this scenario, I can see that y is equal to 2 and x is equal to 3. And if y is equal to 2 and x is equal to 3, I don't think this is a unit circle necessarily, and so I need to find r. Now r is going to be the square root of x squared plus y squared. And so 9 plus 4 is 13. So this is root 13. So r is root 13. Now the definition of cosine of an angle is x over the radius. Okay? So I have to figure out which quadrant I'm in. Now if the ratio that I'm plugging into tan is positive, the only angle I can get out, because tangent only produces angles from negative pi over 2 to pi over 2, it has to be in the first quadrant. Because if tangent's only producing angles in the first or the fourth quadrant. Tangent would be negative here and positive here. And so it has to be angles that are in the first quadrant. And so that means the angle I'm talking about is in the first quadrant where cosine is positive. And so cosine of whatever this angle is, I'm not exactly sure what that angle is going to be the x-coordinate over the radius. Well, I already know the x-coordinate, it's 3, and I already know the radius because I calculated it. So this would be 3 over root 13, but I'm going to rationalize that and end up with 3 root 13 over 13. So this is my final answer. So let's go through the same process again. So this cosine inverse function represents an angle. And then sine of that angle is what I'm interested in. So because this represents the definition of cosine, which I have written over here, is x over r, that means that x has to be the negative thing. So x is -1. And I know it has to be negative because the radius is never the negative thing. A radius is a length, and that length is always positive. And so that means the radius is 4. And so if x is -1 and the radius is 4, I can reverse engineer what y is going to be. 4 squared equals -1 squared plus y squared. And so 16 equals 1 plus y squared. So y equals the square root of 15. So if y is equal to the square root of 15, and I'm looking for cosine of the angle that this would be at, that's going to be y over the radius. So that's root 15 over 4. And that is my final answer. All right, so that's all the material that's going to be on the first exam up to this point. Nothing after this is going to be on the exam. There's a problem set on Blackboard that goes along with this, but the answer keys are already posted. Work through those problems and then check your answers against the answer key and make sure you have any questions that you have ready for me for our review session on Thursday. Thank you.